Hi everyone, welcome. So this is the course AC 132. That's our introductory course to Python programming, and almost every student at Butler University takes that course. So what we are going to cover in today's video is introduction. We'll little bit go over the syllabus, what we are going to cover, and the topic that we are going to cover is loop. We'll also talk about this course, why this course is important, and ultimately then we'll talk about why computer science, why Butler University, and we'll end with some kind of fun fact of computer science. So about me, I'm Dr. Md Munirul Haque. I did my PhD from Marquette University, and after that I did my postdoc from University of Alabama, Birmingham, worked for some time as research scientist at Purdue University here in Indiana, and now I'm working as an assistant professor at Butler University. In my pastime, I like to travel. That's my favorite hobby. I also like to play with my kids. And as you can see, playing with my kids and some picture that I have taken in Uganda when I went there for a NIH-funded project to digitalize their healthcare system. So for this course, we are going to use this textbook named Python by Tony Gaddis. So starting out with Python, and we'll consider that you know nothing about programming language, and we'll start from the very basics, and then we'll ultimately cover variables, conditional statements, loop, function, different types of data structure available in Python, and how that can be specifically utilized in different scenarios. And we'll also talk about array, file, and a little bit of introduction into class. So we'll consider this as the very first programming language that you are having, but ultimately you'll be using the same concept for any programming language you take in further down the semester. So my personal thoughts on computer science. Some people, I always see this type of scenario that some people get it instantly. Within seconds they understand what's programming, how it will work, and so on. But that picture, that dog, that's not you, that's basically me when I was a student. For most of the students, you need the grit and patience to understand how the coding is working, what is loop, why this is happening, why I'm typing this thing and I'm getting this weird error. But the thing that you need is patience. Grit, my friend, will be your biggest friend. Okay, so have that grit. Don't give up, and ultimately it will come to you. Okay? At one point, you will see that you feel confident with coding. And our next slide is, I'm not sure whether you know this lady, but I'm pretty much sure that you all have watched this cartoon named Magic School Bus. That's my kid's favorite cartoon, right? But why Miss Frizzle, this school teacher, is here in my lecture video? Because I liked her motto, and that was take chances, make mistakes, and get messy. And I believe these lines really go with a beginner level coder, right? So whenever you are coding, you'll definitely make mistakes, you'll definitely bog down somewhere, and you are waiting for something to happen. It's not happening, your code is not working, your code is messy, but try it and ultimately it will work out, right? So let's define the expectation at the beginning of this course. Okay, so our course objective is nothing. I have only one course objective for this course, and that is at the end of the semester I want every one of you to feel confident. That I feel confident, I feel myself as a confident coder. If you give me a problem, I don't know how to exactly do that thing, but I feel confident that I'll be able to do that, right? So my expectation from me, I'll do whatever it takes in my power to make sure you get the learning environment to learn how to code. And my expectation from you is be with me, don't fall behind, and try your best. What type of coder we don't want to be? Suppose you write a code and I ask you, I don't get your code, and what are those lines for in your code? And you say, I'm not sure, but without those lines, the code doesn't work. If you are not sure, whatever makes you help to write a rational coding, just write that. I'm not looking for a perfect answer, I am looking for your logical answer. Okay, and now a little bit about Python. I believe it's the most widely popular programming language nowadays. So we'll learn about the foundations of computing and the programming fundamentals. We'll do some real life practical problem solving, and we'll also show how Python can be used for data science projects. Okay, nowadays data science and Python really go hand on hand. And it's so popular that almost every company and every big software that you see, they typically use Python, be it Dropbox, Facebook, Netflix, Google, Instagram, almost everyone. So here is some example. When some students ask me, why am I writing this small code of using loop or condition and so on, I say, you see, COVID-19 is the big hit, big buzzword, right? For the last 3-4 years, you can use Python to generate these beautiful graphs or maps or histograms with the COVID data. Or nowadays, heart rate is a big thing, right? Okay, you can draw these beautiful graphs, different types of graphs. There are many different libraries in Python that you can use. You can include them in your code, in your file, and you can build different types of maps, graphs, visual representation, and so on. Okay, let's talk about one of our topics, and that is a loop. Whenever you hear the term loop, what does that mean? Something that's circle, something that's starting somewhere and ending at the same place, right? We call it typically loop, and we'll basically do the same thing, but we'll see how that can be used from a programming or coding concept. Okay, so suppose it's a summer day in California and it's 100 degree Fahrenheit and you are walking and you need some juice to quench your thirst. Okay, so you go to the vendor. Okay, you take some input, and that input will be some kind of fruits, right? And you do some kind of method or processing. Maybe that is wash it, peel it, cut it in small pieces and blend it, and the final outcome is a nice glass of juice, right? And that is suppose my glass number 1. Suppose I'm not happy. Yeah, I'm too thirsty and I need one more glass, right? Okay, so if I want the second glass, I'm basically doing the exact same thing, right? And now I need more. I'm doing the exact same thing for my third glass, right? So instead of writing, so if you think that the function portion, that wash it, peel it, cut it, and blend it, if that's the same thing you are doing for class number 1, class number 2, and class number 3, instead of writing code separately for each class, what we can do, we can write one piece of code that corresponds to wash, peel, cut, and blend, and then basically say it, repeat that code again and again. And that is basically loop. If I need more glass, need more, then basically just follow the same process or loop, and it will generate the same class of output. Okay, let's see a little bit of more. Okay, suppose this is your loop. You are doing the same thing. So when do we use loop? When you are doing the same thing again and again, instead of repeating the same piece of code, we instruct the compiler to execute a piece of code multiple times. Okay, so that reduces redundancy or replicability of your code. Okay, so here a loop repeatedly executes the loop statement, and we'll see what's iteration and what's a loop variable all in a second. Okay, so this whole thing is a loop statement. What I am doing in each iteration of the loop, one time you go from the beginning to end, that is one iteration of the loop. Okay, and the computer will keep on doing or executing the loop's body or statement until some condition is met, okay, or until some condition is false. Okay, so these are example of iteration of a loop, and this is an expression. So the condition we are using here will keep on preparing a glass of juice until the total glass becomes smaller than, as long as that total number of glasses is smaller than or equal to 3, we'll keep making the juice. Okay, so now let's see in a visual style. Okay, suppose that I have a variable named total glass whose initial value is 0, and suppose n value is 10. Okay, now this is my loop's body. Okay, until I reach glass number 10, I'll keep making juices. Okay, so in each iteration, I'll increase the value of the total glass variable by 1. Okay, and my condition is, as long as total glass value is smaller than or equal to n, I'll keep making my juice. So actually this code will generate how many glasses? So when total glass is 0, is 0 smaller than 10? Yes, I'll make 1 glass of juice. Then total glass value becomes 1. Is 1 smaller than or equal to 10? Yes. So it will make juices actually 11 glass, not 10. From 0 to 10, there are 11 numbers, right? Okay. So this is this part is known as loop initialization. This part is known as loop expression or the condition. This is basically the loop body, and this is modification, where you are changing the loop variable. And this part is actually very important. If you don't have the modification, you will be in an infinite loop. Once total class is 0 and the condition is true, you will make the juice forever, right? That you don't want. Okay, so you must have an initialization, condition, body, and modification. These 4 things create a perfect loop. And the interesting thing here is you don't always need to make the juice, right? Suppose I want to do something 11 times, I want to eat 11 times, I want to meet someone 11 times, and so on. In that case, I can keep my initialization expression and the modification part same, and instead of making the juice, I can change the loop body part, where you are eating somewhere, drinking some number of times, eating food, or meeting someone for coffee, right? Everything, you just change the loop body, the rest can remain the same. Okay. Now, why computer science? I'll just keep it short, and there's a very nice video, and I have given the link for that video, and it says in the next 10 years there will be 1.4 million computer science related relevant jobs, and the interesting fun fact, there will be only 400,000 graduates to qualify for those jobs. So as you can see, there's enough motivation for learning CS, along with, in many times, the average salary is much higher. Along with that, you can spend more time with your family, because many times you can do it remotely, right? And nowadays that has become a big part in our today's work-life balance job requirement. Okay. And why Butler? It's currently ranked number 1, and I think it's number 1 for the last 3 years in the ranking category of Midwest Regional University. It also ranked as number 1 for most innovative school. We are a small school compared to many other big public schools, so roughly 4,500 students. And since we have a small class size that is really preferred and appreciated by most of our students, our class size is fixed at 25. Okay. And we have like major programs in computer science, business, pharmacy, pre-med. We have a very good music, theater, that type of programs also. And one of the big perk of being at Butler is it's located in Indianapolis. It's one of the biggest cities in this whole Midwest, and it's the 14th largest city in the whole US. And Butler, one interesting fact is so this is my 3rd university I'm here, and I have never seen so many female participants, especially in computer science. And the retention rate at Butler, those students who start at Butler mostly graduates from Butler, and our retention rate is over 90%. So that actually says something about Butler and the environment. And 98% placement rate, and roughly 60,000 median starting salary for Butler. And I'll end this video with a fun fact of computer science. So anytime we run a code and there is a problem, there is an error, instead of saying there's an error in my code, we always say there's a bug, I need to debug. That means I need to undo my error, and instead of saying undo or finding the error, we say we need to debug. So bug means insect, right? Then what's the relationship with coding error and a bug? And there's a very nice incident behind this naming, and that is in 1947. Nowadays you use router and so on to send data from one place to another. In those days we had relay machines, and in Harvard one of the relay machines named Mark II was not exactly working. Okay, and the engineers found that a moth died in the relay machine or the tape, and what they did, they took that moth out and they pasted it in their logbook saying because of this bug the machine was not working. And since then, since that 1947 incident, bug has become popular, and nowadays we never call programming error, we typically call bug. And that's the story. Thank you guys, hope to see you sometime at Butler University. Thank you.